Before we get started, I want to make sure we address all questions and concerns. Do any of you have definite questions regarding our system? Okay. Not now, but you will. All right, we wanted to just have you take home some information as far as how to get a hold of us if needs be for service. We've got our address and phone number. We do answer the telephone. Computer picks up first, then you can have some choices, but we will answer it. Okay, here's how to get a hold of us and people on our staff. Names, extensions, emails. We do return messages. If you do have to leave a voicemail, we will return it. First thing I want to talk about today is our control board. This control board is what you've seen for the last better part of probably 8 years. We've had a few revisions, some improvements, and we also have a new board that we'll get into in a little bit. The board is very simple, and the nice thing about our systems is a product you buy today, you can put in unit number 1 we built back in 1999. So we've always tried to maintain that. This is our latest board. This one right here. Fit and function is identical. We have a couple of changes in this one. And we've added an onboard fuse. We've had some issues in the field with some builders using automatic resettable circuit breakers. We don't recommend that at all. If you have buses out there that have those with our system, we recommend you get a fuse in it. Okay? There's been issues in the field with auto resettable circuit breakers. The second thing we've done is we added a redundant ground. Prior to this particular board, all grounding of this system goes through the white wire back to the coach somewhere. I don't know. I don't know where they go. But it heads back to the coach. We have had problems with poor grounds. And you folks all know what happens with poor grounds. All kinds of bad stuff happens. So we've added the secondary ground. If you should get a board as a replacement, if you're replacing with a new one, please find a place on the frame somewhere and drive a screw in it and ground it. Okay? If you go to our website, you'll find this document that we have over the years produced. We have probably 200 models of actuators, maybe a few more than that. For the most part, you're going to be concerned with number 1. And but if you should get an oddball out there, a door that's on the left-hand side of the coach, for instance, is going to be everything in reverse. So it has to be connected differently. Down here is your key, where you plug the wires into the control board, and that'll help you in that change out. Have you all been to our website? ANMsystems.com. There's a lot of good helps on there. And we're going to have a method here shortly we'll introduce to you that's going to make it a little easier. And that's just a continuation. This document, again, the variety of boards that we've used in the past on some of the older buses. You'll find this model right here, probably in 98% of the buses over the course of the last 2 years, maybe 3 years. Prior to that, we had some different models. Again, though, fit and function is identical. We've not changed anything for fit and function. Right? Again, this is a schematic you can find online. It's called Simplified Schematic. And this gives you a nice pictorial on how these things fit together, just what the board does. Now this picture shows solid relays, or contact relays. We don't use them in all models. Some of them are MOSFETs, electronic switching, but still means the same. What? Right. Okay. If you want to talk a little bit about troubleshooting at this point. If you have a condition that the doors will only open or close part way, let me explain just a little bit how this board works. What we have built into this is a current sensing system. It's going to detect the amount of current that the motor's drawing, and then at about 16 amps, it's going to turn itself off. Whether the door's going open and you hit a curb, or a person, or you've got something that's binding the door, it's going to turn itself off at about 16 amps. The same with close. If it comes to the close, on the close, you got a person in there, it hits them at about 16 amps. And by the way, that's not very much pressure. The door is going to close. But what you're going to see on this, can you all see this? There's a red LED. Anytime the board senses 16 amps, that red LED is going to turn on and the motor is going to shut off, whether in the open position or the close. Okay?
Will it stay solid or will it just flash?
It stays lit. It stays lit for about, I think it's 30 seconds. But after a short time, it might be a little longer than that. It might be a minute. Okay, so let's talk about the kinds of things you should do if the door is giving you problems. First thing you want to do is open the emergency release. And by the way, you don't need to push that all the way over toward the forward side of the bus. That puts some undue strain. You're going to be seeing some changes on that too in probably mid next year. There'll be a snap ring on that. You won't be able to push it all the way over. But you want to make sure that the door is free to open and close, that you don't have rust or you don't have some contamination or accumulation of crud down on this lower pivot that's keeping that from opening and closing. So then what you want to do is you want to re-engage. So get your door open, make sure. Now, see if the red light is coming on. If it is, during the part way, we have right here a little potentiometer. And this board is right here. It's got a little blue tape over it. Just pick it off, and you can get down to that. Right turn increases, left turn decreases. Okay, you can adjust this to go from about 12 amps to about 20 amps in current draw when the auto sensing takes place. Typically, 16 amps is more than enough power to close a door. I caution you that I think almost without exception, you should never have that potentiometer turn all the way up. The reason we have that on there, we build 4-foot wide doors, we build 26-inch wide doors. You don't need as much power for a small door as you do a big door. We also build actuators for school buses. Those are always turned on a minimum current. So just for safety reasons. That just points out the potentiometer. Okay, any questions thus far on the adjustment or the operation of this control board? Right, approximately, yeah. That's where we set them at the plant.
Is there an adjustment to where you just completely eliminate that potential mode, or it just goes max 20?
Now, say that again?
Is there like a setting to where you can turn off that
Yeah.
potential?
No, you can't turn it off. No, you can't. But 16 amps is about midpoint in its full range. Before coming in here, someone mentioned that they're having trouble with the door with these seals sticking together. Up until 2010, I think, about there, we used the material, EPDM, rubber. Starting in 2010, this is now TPV. It's more plastic than it is rubber. It's more pliable. It doesn't shrink. It doesn't expand with weather changes. It's much more durable. It meets the FMVSS burn requirements better. And it's totally recyclable. So we went to this product simply, mostly because of the shrinkage and expansion problems of the other material. This doesn't do that. It's stable, won't change depending on weather. But on the older units, if you have trouble with sticking, you can clean it off and put some floor wax or automotive wax on there, and that'll keep that from doing that. Someone else said they use silicone. You could use that as well. I know silicone is is frowned upon in some places, especially if you do any painting. But a wax product on there will do well. Okay. Slop in the doors. Carrie and I were just over to the plant this morning doing an installation on it. And right up in here, there's a set screw that's in there intended to take away any little bit of slop there may be in this door. In the last 4 or 5 months, we've gone to a different actuator arm. This is now a welded steel part. Prior to this, we had a sintered metal, and sintered steel, they take granulated steel, squeeze it together to the final shape, goes through heat treat, and you have a solid steel part with all the same mechanical characteristics of solid steel, with the exception of impact loading. If you remember the old style, if you tried to hammer these on, what would happen? They'd break in a heartbeat. So you had to handle them very, very carefully. The design load in this direction, they had lots and lots. They had over 500 foot-pounds of torque that they would hold, and we only have the availability of about 300 at this point. So it was much strong. It was strong enough, but these are even better. We have total control now of the hex size. So when these go together, there's very little lost motion in that. It's a very nice fit. This should be a great improvement for you for installing if you have to take doors out or change them for whatever reason. Should help a whole lot. But anyway, check these set screws periodically, make sure they stay tight. It wouldn't hurt to put a little Loctite on those, blue Loctite, to help the set screw stay in position, stay tight. Okay, open limit switch. I can't emphasize the importance of maintaining this gap. This is looking, and I realize, looking at this unit right here and a picture, I mean, this is optimum position. I mean, you're down here looking, working like this on these darn things. It's really hard to see. But make sure that this, we call this a spacer, rod-end spacer, never makes contact with that stabilizer. And what determines that, this position right here, is the location of this actuator tab to the micro switch in the open position. If this hits, what happens is the diminished life on the motor. What's happening is you're getting metal on metal and you're stopping everything right now, and it's really hard on all the mechanics. Now we have built into this control board dynamic braking where electrically that motor spools down quickly as soon as that open limit switch is hit. It spools down very quickly, so we can maintain a very close gap. But it's extremely important, especially when you're changing a motor. As a matter of fact, we have a warning label on here reminding you to check that gap. Okay, does that make sense? Very important. Open limit switches. These things are kind of fragile. I don't want to say when they're used in the proper manner, they work well. What happens sometimes when somebody's in there is you may hit this switch tab and move it over, and you go to open the door and it knocks the switch off. And that's not that uncommon. If it cracks, and we've had them on the field where they might crack and the contacts don't change. What this limit switch is doing is it's giving a micro switch in the board an open condition on a microchip that tells the board to do its thing. And it really is not, it doesn't open the circuit, it's an input to a microchip. So don't expect to read any voltages on here that mean anything to you. Okay? So you can take an ohmmeter or a voltmeter, it's not going to, it won't mean anything. So, because it's an input to a microchip, looking for an open condition on a micro switch. Let me just say also, we changed the way that we attach the micro switches as of probably first of this year. We now put threaded inserts down in the base plate as opposed to trying to tap this. We have a much better thread, easier to get the screws in and out. It's not going to bite up on you. I know that's been a problem. Here's just some ideas for you to start looking at when you have a condition that the switches may not be working correctly. Another thing we did here a few years ago was we put on these connectors so you folks can't put them in the wrong position. Again, you're working up like this, maybe with a mirror or something. This makes sure that they're put on in the right position. We've had numerous calls over the years. Hey, I put a new board in and it still doesn't work. Well, are you sure you got your switches in the right position? Because if you have them in the wrong position, that open limit switch is going to think the door's already open. The door, it will not drive the door, the doors to the open position because you got these on the wrong place. Okay? This is just another picture of talking about the importance of that corrosion. What can I say about corrosion? If you have corrosion up there, you got a roof leak. Don't just change the board without fixing the roof leak, because these things are potted, but they are not completely waterproof or water resistant. Okay? Okay. Let's talk about troubleshooting this system. First thing you want to do when you have a problem, the door's not functioning, you can backfit this. Please don't pierce the insulation in your red wire. This red wire, you can put a probe right down into the back side of the connector, and you can read voltage. This is 12 volts continuously. And it should be 12 volts even with the ignition off. As I mentioned earlier, that's to be fused. We recommend 25 amp fuse, not a circuit breaker. White wire is ground. And then these two are intermittent open and close signals from the switch. Open is blue, close is orange. It's very simple as if the door doesn't open, you push the open, have somebody push the door open switch, and you come in here and you check voltage on the blue. If you have voltage on the blue, that says the switch is working. You probably have something wrong with the board. But additionally, we have LEDs. Check for LEDs on the board. Green is open, orange or amber is closed. Okay? Pretty simple. You can diagnose this thing usually without a voltmeter, with the exception of checking for 12 volts. Again, just some things more or less what I just talked about. Okay. I haven't heard of this in the recent past, but it's quite common to diagnose these things by sticking a meter probe down in these holes. Don't do that. You'll have to replace this lead here if you do, because what happens is it opens up the spring on these and they'll lose connection. Then you'll have a lot of problems. So you can just touch the end of it. You can touch it on the bottom. One side is going to be 12 volts in the open position, and the other side is going to be 12 volts in the other, because the opposite side goes to ground through the board. Okay? The motor has no grounding in and of itself. Everything goes through the connector. Okay, other intermittent and odd problems. When we get a phone call that says somebody's having a problem, something strange is happening, they're getting voltage on both the open and the closed side, the first question we ask is, does it have an outside key switch? Many times they'll say, yeah, well, disconnect that outside key switch and call us back. And most of the time we don't get a call back. We do have a solution. It's a very easy solution. Is this touchpad. And you can remove the key switch, and this goes right over the hole. It's attached with double stick tape. It's high bond, 3M brand double stick tape. And then the connection is all plug in. In the case of, if this is your coach wiring right here, this is what the coach will have. This is what will be on the board. This harness just goes in between. It's just plug it together, plug this into the end, and stick it to the bus. And it's very easy in its operation. And this got broken off getting out here. What happened to our
door switch, door wire.
What's that?
Door wire, you're on plug it.
Door motor on.
Certainly. Thank you.
Just give us a call anytime. Disconnect your external switch.
These all come with the same code 1845, which was our old street address. And then it's just push and hold for open and close. This stays active for about 30 seconds, and then the backlighting turns off, and then you have to re-enter the key, and then the open and close to make that operate. These things have worked very well. And this is just, more verbiage of what we've already talked about. Okay. This little manual release lever is intended for emergency use, not repeated use. One of the things we found that people want to crank it all the way over to toward the front of the bus. You don't need to do that. Pull it right straight out. The door should release, and you can go ahead and just a little past. What we're going to be having here in the next, probably mid-next year, is a snap ring on this. I'm sorry. Will be a snap ring that will limit the amount you can push that over. So any problems that you've had out in the field with bending or breaking or all the above should be pretty much eliminated. Now, I imagine a Gorilla can get on it and do some more, but it should be a great improvement. In fact, we put a label on that now. Unfortunately, when these things are installed, you don't see it anymore. But that label is actually right here beside the emergency release lever. Okay, ratcheting sound coming from the actuator. See some smiles out there. You've heard it. And the problem is broken teeth on the gear. As of about the beginning of next year, you're going to see a different motor. This one has a whole slug of holes on it. We, over the years, have used as many as 3 different motors for different applications. This motor fits all applications, and it has a solid steel gear. Our former motor had a centered gear. We do have replacement gears for those. Eldorado has stocks of them. It's easy to replace. We find that probably 98% of motor problems is this gear. The motor itself is tough. Anything on warranty we've replaced has always been this gear. Have any of you experienced anything other than what I just said? Okay. Our Siemens, the motor that we've used for almost 10 years, was built by Siemens, and then they sold it to Brose. Brose is a huge automotive window lift builder. We went out a little over a year ago, maybe close to 2 years ago now. Found a company to build us a motor to our specifications. The former motors, we would get around 250,000 cycles. This motor, we've gotten 800,000 cycles plus. It's a tough motor. They've allowed us to give direction on materials so that the gear end of it is tough, that there's some spacers and some thrust washers within the motor that they've allowed us to help engineer and produce a motor that is outstanding in its quality. I think that you folks, if you are habitually selling motors, I don't know if it's a good thing or bad for you folks that are out there, turning a nickel with these things. We probably won't sell so many motors down the road. Okay.
Did that change already happen? You said there.
Did what?
Did that change already happen?
No. This will be. We're still using a whole stock, and our new supply is limited, and we'll be in full use about first of the year.
The old one, about how many cycles does it last?
In our testing, we've got somewhere around 250,000.
About 4 months.
Now, when we test it, we open and close the door every 5 seconds, 24/7. So every 5 seconds it opens, and 5 seconds it closes. And it takes about 3 months for that to finally fail.
So you're counting 250,000 times opening and closing? That's one
correct.
cycle?
No, movements.
One,
To about 250,000 movements, so in this case, it'd be 125,000 cycles. And of course, that's gonna vary. It's gonna vary on the actual application. You know, if you're picking up folks in New York City Airport, or if you're picking up folks from the casino, it's gonna make a lot of difference, you know, how it's actually used.
what's the warranty on that motor?
Best to check with Eldorado. Yeah.
What's your guys' warranty on it?
I don't know what Eldorado's warranty is on that. I'm not sure. So
It's not
check.
warranted through A&M?
We deal through Eldorado in replacement parts. Oh, okay. Ratcheting south. You want to look for broken teeth on the, and there's what that replacement gear and looks like. But what you're going to want to also do, again, probably 3-4 years ago, these main gears used to be sintered steel. These are now solid steel gears with hardened teeth. You probably have seen in the past that a tooth will break periodically. That will also cause a ratcheting sound. But the best thing to do is to pull these 3 bolts, take the motor off, open and close the door, look at the whole periphery of that gear, and make sure you don't have something wrong there. And I can't emphasize lubing enough. We do not send these to the plants lubricated because grease is a dirt magnet. And so when these are installed, the instruction we give the OEMs is to use some white lithium grease, and wherever the gears make mesh is where you should lube. And you really ought to do that at least on a yearly basis, maybe even a semi-yearly basis. Just look at it, give it a shot of spray grease, and you'll find that everything will work much nicer. All other moving parts are oil-impregnated bronze. Oil-impregnated bronze on these rod bushings, on these main pivots here, on our gear pivots. Again, we've got a unit on our test cell that's got 2 million cycles on it. We've never done anything to the mechanics. We have lubricated it, and just let her go. Okay, identification of product. This is the inside of the bus. You're looking to the outside of the bus. On the aft side, there's a label. It'll have product identification number and a serial number. We need to have that information in order to get the right parts. So that's extremely important. The other thing we have is on the door leaf, either right here on top of the torque arm or out here, one of those 2 locations, top of the door, product number, serial number. We track, we maintain files of all units produced. We can tell you the day a certain item was produced by having those numbers. I included here in this packet programming information for this touchpad. Very simple. Now there is one thing that may not be good. If you lose the last code, you get to buy a new touchpad. There's no back door into reprogramming it. We did that on the side of safety. That anyone that knew the backdoor code can go in and reprogram anything that we've ever go. So you must know the last code if you want to program a new number into it. Out of the plant to come 1845, or you can change that to whatever you want. I think that's all the slides. Okay, questions?
Does the keyless entry retrofit the old, anything that has existing key in it now?
Anything, it will plug in to any control board that has the modular type plugins. And we've been doing this now for 6, 8 years.
Okay.
And that, but even before that, it's easy to wire up. It's a railroad.
I guess the same goes with new pivot, steel pivots you have for actuating. Will that replace the old sintered metal?
Yes, absolutely. Absolutely. In fact, you won't, anything that's, if you order the part number, it's probably the same part number because they're fit and functions exactly the same.
74?
I have no idea. I have no idea what the part number is. We do have also a wireless key fob operator. Again, that's extremely easy to install. It's a plug and play. Comes with a harness. You disconnect the coach wiring, plug the harness in, plug the harness back in into the control board, and then you have this little device that you just put up on the header plate. And you can program, probably program 10 key fobs to the same header if you wanted to. So, or if you want to have them all different, they're reprogrammable, they're easy if they get lost or driven over, they're easy to replace. It's just like your garage door, you punch the red button and you press open or close and watch the LEDs flash 3 times and you're all reprogrammed. This is also rolling code.
Is that something new?
No, we've had this for a number of years. I will say that the old ones were junk that we sold. As compared to these are highly better. It's a real nice unit. Questions, concerns, comments? How many of you replaced door glass? Is it a hard job?
No, once I figured out how to do it.
Yeah. Yeah. Actually, I'll bet you that it's easier to replace door glass than it is to put it in the first time.
Yeah, the first time was a nightmare.
Well, because the glazing gasket is, once it takes a set, it'll stay there, and the glass should slide right in.
Yeah.
How many of you had doors that separated at the mechanical junction out here, the screws? Have you had that?
Not recently, but before, yes.
Early on, we have a different manufacturing method now. We have different hardware. I don't remember the last time we've had an issue with one coming apart. It's been a very long time. What we've found is particularly on big doors and installations or routes that were on rough road, and you get this up and down, all these, they're called vertical load moments. And that is really hard on a mechanical joint. We strengthen this considerably, change the way we assemble it, and like I said, I don't know the last time we've had an issue with one coming apart. We can do thermal painting, we can do laminated glass. So if you have customers out there that, particularly those up in the north, that need thermal glass, we do a lot of thermal glass for school buses. But that's it's real easy for us to do, and it's not that expensive. Anything else? Talked about everything, Gary?
Talk to everything.
How waterproof is that keypad?
All right, well, we'll be over in the area if you want to come up and see this or have specific.
Is it waterproof keypad? And how waterproof is that?
The control board?
This right here for outside.
It is, yeah. You stick it right on the outside of the bus, it's paintable. If you, yep, sure is.
As long as you don't put a screw through it. We've had one incident where somebody put a screw through it and realized it didn't work. And then when they took it apart, oh.
Did they want warranty?